Given that the length of each side of a quadrilateral is a distinct integer and that the longest side is not greater than 7, how many different possible combinations of side length are there? So, first of all, the possible side lengths are 1, 2, 3, 4, 5, 6, and 7. So it can't be greater than 7, but we have to pick 4 from any of those 7. So naively, we might think what we're going to do is 7 choose 4, and this is certainly a good start. How many different combinations of 4 can we choose from 7? 7 choose 4, and of course this is going to be 7 factorial over 4 factorial times 7 minus 4, which is 3 factorial. That's 7 times 6 times 5 times 4 factorial, which cancels this 4 factorial, and 7 times 6 times 5 over 3 factorial, which is 6, that cancels. And so then we get 35. And you would think that 35 would be the answer. You might think that if you're just relying totally on the formula. And if we were asking just the question in the abstract, take these 7 numbers, how many, or any 7 objects, how many different combinations of 4 can we pick, then 35 would be the answer. But we have to think about the geometry also. Are all 35 of those going to be possible? And the answer is no, because they're sides of a quadrilateral. Well, a quadrilateral is a closed thing. And so think about the sides of a quadrilateral. Suppose we had a length of 7. We have the longest side. And suppose we pick the 3 shortest numbers, 1, 2, and 3. Well, 1, 2, and 3, that wouldn't be long enough. No matter how much these 3 short sides stretched, they could not equal the length of that long side. And so it's a problem. First of all, 1 plus 2 plus 3 is less than 7, so that's a problem. It's also a problem if the 3 shortest sides equal the longest side, because then you'd have a flat thing. You'd have something stretched flat instead of having a quadrilateral, which is actually something that has to enclose area inside it. So 1 plus 2 plus 3 equals 6, or 1 plus 2 plus 4 equals 7. These would be the 3 cases that are prohibited. Okay, once you get larger numbers than these, then you can have a side of 6 or 7. And of course, any 3 numbers added together are going to be greater than 5, so that's not going to be a problem for any of the smaller sides. So these are the only 3 that are prohibited. So we have to subtract these 3 prohibited cases, and we get 32, the legitimate number of sides. Answer choice C.